Okay, welcome everyone. Thanks for joining. Today we're showing a webinar on Expanse 101, Accessing and Running Jobs on Expanse, SDSC's newest supercomputer. Mary Thomas is the presenter today. Mary is a computational data scientist and training lead at SDSC. But before we begin, I'd like to share a couple of slides. The first relating to Exceed's Code of Conduct. Exceed has an external code of conduct, which represents our commitment to providing an inclusive and harassment-free environment in all interactions, regardless of race, age, ethnicity, national origin, language, gender identity, sexual orientation, disability, physical appearance, political views, military service, health status, or religions. If you everyone is usually on their best behavior, but if there's anything you feel the need to report, the details are at exceed.org/code of conduct. And Exceed is also making an effort to update our terminology. We're committed to providing training events that foster inclusion and show respect for all. If you in the event that we have included inappropriate materials, verbal or written, please let us know at terminology@exceed.org. So with that, I will stop sharing and hand it off to Mary. Take it away, Mary.
Hey everybody, welcome. I'll turn my video on just for a moment. Thanks for showing up, and let's get started. So I will share screen. Desktop 1, share. All right, so you should all see yourselves. Before I get into the talk, I want to point out a couple of web pages. They're mentioned in the talk, but this is the Expanse page. It has some of our latest information, and we're updating that. And then there's our training site. So we have a way for you to filter now to see training events based on the system you're interested in. And then this is a tutorial coming up if you're really new, and if you've been on Comet for a while, we have a short workshop planned to help you transition. I'll talk more about that, but Expanse is a brand new clean system. Your home directory has literally nothing in it. And this is with intent because this machine is different from Comet. So think about that, and we will repeat this tutorial in the new year as well. And then this is the webinar we're at today. We also have a site with interactive videos. Jeff has a method for taking the webinar like today, and he'll convert that to an interactive video where you can navigate and drive through the webinar and see the text and get more content extracted out of that. So without further ado, I also want to mention that hopefully you can see my talk and it looks good. We have a few people from the Expanse staff, Mahidar and Marty and others, who can help with chat and answer questions because I can't see it. So ask away. Jeff will record all the chat and we'll share that as well. So you have all the information from today that you can refer back to. And then eventually my talk will be translated to a markdown file where it's a sort of a hands-on tutorial for you to cut and paste and practice from. Okay, so there's an outline. We'll start moving through it. I have a lot of slides because there was a lot of material that needed to be included, but we don't cover all of it today, but it's just there for you to check. So I already pointed out some of these references. We do have some repositories where you can go and look at the basic skills, the things that you need minimally. It's useful if you're a new user and you need to know how much Unix do I need to know. The basic skills will help you with that and show you how to log on. I'll do that very briefly today. Again, we have the Expanse transition. Looks like my link needs to be fixed there. And then we'll be doing Jupyter Notebooks in December, running those on Expanse. And then we have several events we're planning for the new year. So let's move to a quick overview of Expanse. If you want a more detailed one, Mahidar did an introduction to Expanse back in June. And so I'm just including these for completeness, but Expanse is a large system. Again, it's designed for that long tail of science. going to have about 5 petaflops of computing. We have these scalable compute units that are consisted of standard compute nodes, CPU, AMD EPYC processor on those, and then GPU nodes as well. I'll show you a little bit of that. If you want more detail on all of this, again, go to the website or to Mahidar's. I want to get to actually moving to where we're doing some work on it. So for that, this is just a summary. It's very heterogeneous architecture. We have this concept of a rack that's a scalable compute unit, and it contains CPU and GPU resources on each rack. Our CPUs are the AMD EPYC with 128 cores per processor and per node, excuse me, so that we have a lot of power on each of the racks, which gives you that local distance data-centric kind of ability. For data, we have a Lustre, 12 petabyte Lustre system and Ceph object storage and high-speed network interconnections. So we're again designed for that long tail, which means most of our jobs are expected to be small, a few thousand cores maybe, or a little bit more, and that these jobs will be prioritized and scheduled and run faster. So the idea is to give more people that opportunity to run their jobs. So that's, if you have that kind of job, that's where you belong on Expanse. The connectivity fabric is high speed, 200 gigabits per second between the Expanse nodes and the Lustre and the Ceph storage, and then high speed network out to the large Exceed computational science network. So the real quick overview of the processor architecture. I am not the expert, but it's very complicated and it's different. It's very efficient, but it does present some interesting challenges for when you're writing your batch scripts and deciding how you want to parse your job out on the node. And again, Mahidar has his talk where he goes into it in a little more depth. But the idea is that on this EPYC processor, you've got these CCDs, core complex dies, and then they break down to these CCX modules. So you have the Zen 2 core there and memory, and they share memory between each other. And the way you build up your configuration and your batch script and your code is really dependent on the architecture of the EPYC processor. And so we'll be doing a lot more training on how to use this, and the AMD HPC user forum, I'll talk about that at the end. We have that, we're putting that together. We had a kickoff meeting, and the goal is to be able to get some training for people and communication between different groups of people doing different things on the processor. So we have some new unique features that will be coming online in the next few months. One is composable systems. And the idea is putting together dynamically on the fly a complex system that does a workload for you and supports the workflow. And it will be coming online in the next month as well. And we'll be doing some training on this in the early spring of 2021. And then also we're integrating public cloud. This is led by Ilkay and her team. And we're integrating with the public cloud. Trevor Cooper and the ops group have been putting together, you submit a job to the Slurm and it can go out and dynamically grab some cloud computing resources. They've been testing Amazon, AWS, and then they'll integrate other clouds. I think that will be coming online. I'm not sure of the dates, but we will be having some training events for that. So Expanse status, just to give you the latest and greatest, it's a beautiful work in progress. We're in the early user phase, and we're learning a lot about the system and getting all the pieces together. It's a big system, and we're moving into production on November 1st, and Comet will be running until March 2021. And that's why we're doing this transition workshop to help people get everything they want off of Comet, because you literally do not have you have the very minimum information in your directory. It will not have any of your commit code files or folders. You'll have to bring them all over and then bring them all over in the right way. And one of the biggest changes is the system we use for modules. So getting started, you need to be able to log on if you're new at that and don't know a lot about SSH and SSH keys and certificates. We have some tutorials online in the basic skills repository. So we have single sign-on through the user portal, so you do need to get an account on there. You can get a startup or a trial account if you don't have one yet. And then you want to use your exceed-wide password. Note that the CPU and GPU resources are allocated separately. So you log in, but then you have to get onto a GPU node if you're going to run GPU code or submit it to the batch script, and you need an allocation for that. So the domain name for Expanse is login.expanse.sdsc.edu, and this is an example of using your Expanse username to log on. Again, we have some links to a repository with more hands-on tutorial material for that. Using your keys, you can put your public key into your authorized keys file on Expanse, and then you can have password lists. We're recommending that you work with SSH-auth, SSH agent, excuse me, to avoid repeatedly typing a password and to be a little more secure. So again, if you're not familiar with what's a cluster, you're over here on your thin client, your laptop or a local workstation, you're going to log in and you get onto a login node on the cluster. You're not on one of the high-powered nodes. And that's separate physically from the cluster. And so when you want to run jobs on these nodes, you have to work through the queuing system, and we use Slurm, and I'll talk about that. Most people these days are Mac or Windows, and Mac has a great terminal, and Windows does too have one. You can use PuTTY if you want, but the Windows 10 terminal app has some pretty good reviews. So try and use those too. It'll simplify your access. There's an example of logging on. Typically there's a welcome message and a message of the day, but right now you can just log on and figure out who you are. Getting the tutorial example code. We will have the example code. It's on this repository right now under an examples directory. So you can clone that. If you don't know about cloning, we have using GitHub, you can Google that. Hopefully you know how to use Git, and you have a GitHub account, so that will simplify things for you. If you have trouble, just contact us. And there's the directory where all of the examples are that we'll work with today. All right, so you have the examples. Right now there's 4 major folders, directories, and we'll be adding to that. There's an MPI example, there's OpenMP, and there's a GPU and a hybrid MPI OpenMP example. Several of us have tested these, they run. And today I'll go through some of the work I had to go through to make them run on Expanse because it's different. So if you don't know the Unix commands in our basic skills training repository, you can follow a hands-on tutorial that shows you how to do basic skills, the basic Unix skills that you need to know. Using the login nodes, just a warning, they're just meant for simple things, editing, moving files around. Computational demanding jobs need to be submitted through the batch system or on an interactive node. Jobs, if you use up resources, your jobs could get canceled. So the login nodes are not the same as the batch nodes. So you can request an interactive session if that's what you want to do. Coming soon, we have the Expanse user portal coming up. It's based on OOD, and it's going to be a nice way to log in, submit jobs, monitor them, and you'll also be able to launch a terminal shell from within the portal to get you connected to Expanse as well. I think that the Comet, there is one on Comet at the moment, and the Expanse user portal will be coming online soon. If Mahi or somebody knows a date, maybe they can put that in the chat. So let's get to the meat of the problem, or the challenge is modules. By now, most of you who work on HPC systems you're familiar with modules. You know how to use the modules on Comet, but we use a different module environment now on Expanse based on the Lua LMOD system. And I found a very nice tutorial here on Elm that was really helpful for me as I was learning the module system. Their examples are clear, and everything I tried worked pretty well. You want to make sure you're looking at the latest version. So the way it's set up is like with all modules, you're going to set up custom environments, and the way Expanse has been configured is you have some default, but it's very minimum. It doesn't even know about the queuing system, so you have to load the Slurm module in. And in all of our examples, we have a formula that's in the README file. We have the module formula in the batch script examples as well. So every time you run a batch script, you need to load the modules. So there's it's a blessing and a curse. The blessing is you'll have exactly what you need and know exactly what you need when you run your jobs. The challenge is that you have to remember to load these things in. And I'll show you a couple of tricks for having a default environment. When you do log in, you can put something into your bash scripts. So what's the same on Comet? Dynamic modification of your shell environment. You can set, change, or delete these environment variables and modules, and you can choose between different versions of the same software or different combinations. One nice feature of the LMOD system is it looks for dependencies and tries to modify dependencies. So if you change your Intel version, it might change some other version of software. If it can't, it gives you some recommended commands using a command called Spider to look around and see what you do need. So they try to make it as minimally challenging as possible. So that's kind of a fun thing to do. And so what's different? You will not see all the available modules when you try to run a command, like module available. You have to initialize your system by loading in some kind of a compiler, because what you'll see is all of the applications and libraries and packages associated with that compiler. So again, it's a clean start, and you can reset everything by unloading all the modules you've loaded. And so if you're trying to find information, you can use module Spider. There's also keyword option. And again, their feedback that is really helpful and informative. And once you get to kind of know how that works, you can find what you need. And if not, contact the Exceed Help Desk. The paths are different for CPU and GPU. So you may log on to CPU, but when you go to the GPU, you have to reload everything. So if you need to know about GPU, you need to load this high-level CPU module, and then if you're on GPU, you'll need to load the high-level GPU module. But I did discover that there are some libraries that, even if you're not going to run on GPU, they require that you, like an Intel library, you still have to load the GPU. So there's no harm in loading both, but you'll kind of figure that out. So here's an example of using module. You can list the modules. That's normal. You can get information about a module. And this shows, I get default this is when I log on what I had one day, at one time when I was in the environment. And so you can look at modules available. And because I know about CPU, I can load these in, and then it would give me some information. Okay, and I snipped it because it's longer. Whenever you see snip in my slides, that means there was more information than I could fit onto a slide. Here are some of the more common modules. By the way, I want to also point out that my talk follows the Expanse user guide, which is now available online, and you can get to that from the Expanse webpage. So I'm trying to make my talk follow the user guide so you can co-check. and refer to both of them. So this is a list. I did learn something about shorthand notation called module load. ML is a shorthand, and you can add or subtract modules, load and unload. Okay, so load a module and verify that it's changed your environment. This is sometimes you need to know what's happened to your environment, especially if you're moving around through a lot of coupled models or whatever. So you can look at your environment and figure out what you've got in it. And again, this is chopped down. And so then I wanted to add HDF5. So here there's no mention of HDF5, and then I added HDF5 and you can see that it appears. So if you run the environment command, then you can find it. And you may need to be doing that inside a script. So here again, it's sort of a repeat, but here I looked at the environment and looked for HDF5. There's no HDF5, I add it, and then I grep for HDF5 and I find it in a lot of spots. So yay, I've got HDF5. So I've used this technique inside a batch script or even in code to make sure I've got what I need. And when you log out, all that goes away. So when you log out, the entire module environment that you've built up goes away. And so you can control these modules. You can override and put some, this should be in your .bash profile, for example, in bash, and then in your .bashrc file, put this line of code. And this came from that Luau LMOD tutorial, by the way. And then any module commands that you want, you would put here. Like I put in module load HDF5. So when I log in, that's loaded in for me. So you can also have a default environment that you want to log into. So there's my bash profile, my .bashrc, and log out and log back in. And indeed, I logged back in, and there's my HDF5 library loaded in and ready for me to use. Sometimes the commands are not found, and this we found on Comet, and I think it's still here. Sometimes things just get messed up. You've been changing and switching modules, and the system can only do so much. And so there's a script that will resource your environment for modules and clean that up. We recommend that you use that and that you consider putting it into your scripts as well. All right, so account management. I want to make sure that we have time to have some questions. So just real quickly, that you all know from Comet that there's account management code, and so you should make sure you're always using the right project so you don't overspend your account, and that these projects are awarded through the allocation project. So you need to, you'll see this line in a lot of our examples, especially in the user guide. You put your project in that line. It will by default pick up your basic default account. So there's a new script called Expanse Client, and this is some information on how to use it. So you can run a help. There's some more explanation in the user guide about how that works. So if you want to add a user, it's just the same as it used to be. You go to the Exceed portal. Charging, you have to be careful how you're getting charged. Again, the CPU and the GPU are different. They have different allocations and different charging mechanisms. The Expanse, there's the service unit is our basic charging unit, and they're based on the resources tied up by your job, not necessarily whether it's working. So if you ask for an interactive node for 5 hours, but you go off and have coffee and you don't do anything, you're going to get charged for that 5 hours. The same thing with the batch script. So be aware of that. And they're based on number of cores, fraction of memory, and other factors. And this is, again, keep checking back in the user guide because it's a work in progress as well. We're updating it based on our early user experiences. So a lot of material, even in my talk today, reflects the state of the system and our documentation. And I'll keep updating this, but go to the user guide for your final information. And if it doesn't make sense, send an email to Exceed Help. Some considerations about job charging. Um, I'm not going to go into this in too much detail. This is actually, you can also find it on the user guide. So accounts, right? You need to know, looks like I went the wrong direction. Compiling. Okay, so supported compilers on Expanse. This is where it gets a little complicated and where you need the modules. On the CPU nodes, we have GNU, Intel, AOCC, the AMD compiler, and multiple MPI implementations, and you'll have to be able to find the modules for these and get the right associated libraries loaded with it. A majority at this point in time, many of the applications have been built with GCC, which has Rome optimizations, AMD EPYC Rome. And there's the Intel and AOCC, of course, they all have flags for Rome, and they support AVX2. Often on machines, you find that the GNU compilers do just as well. So don't worry about which one you're using. Use the one that maybe is most familiar to you. So you'll find in our user guide for each of the compilers, there's a table that reminds you of what the different commands are. And I find this is very helpful depending on Fortran, C, C++, and there would be other languages supported. But we have the serial, the MPI, the OpenMP, and then the hybrid. There, I don't think that there's one. You'll find a similar table for GPUs. Sorry, I will be getting to that in a moment. And so the AMD AOCC compiler is only available on the CPU. For the GPU, we have NVIDIA GPUs, and we'll have their compilers. AMD makes their own GPU hardware, and so they have their own GPU compiler for their hardware. And so if you want to load the AOCC, it should be just as simple as this, but you might get feedback from the module system if you haven't loaded the CPU or the GPU. So you can get compiler help, for example, for flang, clang, etc., using the help command. So using the AOCC compiler, in our help examples, we try to include examples of using all the different compilers. We have that at least for Hello World MPI. So you want to check your modules and see if you have what you need. Right now, I've got these different modules, but I'm going to change it for an example. This one here is just to show you how to change it. You do module purge, just like on Comet. You list your modules. There's no modules loaded. Then I start loading in different modules, and then I list them. And we can see that I have the Slurm, a CPU, GCC 10.2.0, and OpenMPI 4.0.4. And then I went, oops, I don't want to use GCC. What do? Do I have to purge and start again? Because remember, the version of OpenMPI that gets loaded is going to be dependent on that GCC. And so what I did was I swapped the Intel, and I said, oh, I want to go ahead and use AOCC. Sorry, that's a typo. That should be a swap of GCC. It did swap it and also made a substitution. And now I have AOCC and the correct OpenMPI version associated with AOCC. So you can see this nice fluidity between making changes and getting the right modules as a result, instead of having to figure them all out. And you might want to record that that's the version you want as you go along. Are we doing okay on questions, or do I need to slow down?
I think it's being handled well by Marty.
Okay,
and Maida.
great. Yeah, if I need to slow down, I'm flying through this because I do have a lot of slides, and I want to make sure we kind of loosely cover it, and then people can ask their questions. And I do have time at the end for questions, so we don't have to stop immediately at noon. All right, so the Intel compilers, the whole system works about the same. We have Intel on the GPU and the CPU and the GPU. That's a typo. that should say CPU and GPU. Here are the Intel compiler commands. They are the same ones. They haven't changed. It's just the way you get them loaded in. And we have these 3 examples should have included the batch script with the compiler command information in it for the Intel. And so to use it, again, you could put something into your startup scripts if you want. So I'm looking at my modules. There's no Intel. I'm working with that previous environment. So this time I just decided to purge and load in Slurm CPU, Intel, OpenMP, and the system, of course, I have a typo in here as well. I apologize for that. That should have been replaced with the Intel. So apologize for that. So for using them, we have the advanced vector extensions and the math kernel library. So you want to make sure when you try to load in the math kernel libraries that you use the right set of instructions. And that was a learning curve for me to get the right ones for that. I have an example later on showing that. The GNU compilers for CPU and GPU work the same way. And that's an example of the module environment. For GNU compilers, these are the commands that we're using and recommending. The PGI compiler only works on GPU. Remember, PGI was bought by NVIDIA, and so we're only supporting that down on the GPUs. So to compile, you have to first get an interactive node and then load the right module and then compile and then exit the interactive node if you don't plan to run your code. I have an example for that down below. So you want to make sure you've got the right environment and that you have the right MPICC version. The recommended PGI compilers are similar to Comet. They haven't changed very much, except you can only use PGI down on the GPU devices. So for those of you who've been using PGI, that's going to be a change. Okay, so let's spend the rest of our time just trying to run jobs and show some examples for that. So for those of you who are new, there's different parallel models. The main ones are distributed memory and shared memory. And in distributed memory, you can imagine your jobs running on each one of those racks out in the machine room for Expanse, and that for jobs to update information and share, it has to go send data through an interconnect. So you have a bandwidth issue there. And so that's distributed, and message passing is one of the most widely used ways to communicate between the different distributed CPUs or cores that are running your job. Then there's the shared memory, and this you would typically do for all the cores that are on the node that you're using on one of the racks, and they're all architected to shared memory. Now this is a very naive, old school model. The EPIC architecture, if you look at it in depth, it's got several levels of cache between the core and the other 8 cores that are on one of the CCXs and then the CCDs, so that the communication is complicated, and you'll want to be aware of that, because for your particular application you may need to do some tuning, and that's going to be part of the role of the support group, but also the AMD user forum that we're putting together. We're going to have special interest groups and working groups that will be working and helping each other make progress on that. So that's just sort of for new people, and then trying to run the jobs is different, and just that caveat to remember that, you know, when you run in a batch mode, you submit the job to the queuing system, and I'll explain that in a moment, and that computationally intensive jobs should be run only on compute nodes or interactive. And we do have some limits on the number of jobs you can queue up and how long they can run, just like on Comet. And if you have to submit a large number of jobs, it can impact everybody. So if you're having some trouble or you're concerned, you might get in touch with the staff on Expanse so we can help you facilitate. It's not that we don't want you to do that. I just want to make sure you're using the resources effectively. It saves you CPU time and makes better use of our resources. So we get to the concept of what's a queuing system, and we use the Slurm Simple Linux utility for resource management. Slurm is becoming more and more ubiquitous. It supports and manages running batch jobs and interactive jobs. And I have two examples of interactive jobs that, for me, worked all day yesterday, all the time I've been running them. So hopefully you can grab these and use them as well. Interactive jobs are you get a cluster node. So here's a layout of a cluster and the Slurm. This may be outdated, but how a queuing system or a resource manager works. So you're trying to run a CPU or a GPU job, and you have to get onto the cluster, but we don't let you in. You have to put together a job request using something called a batch script, and then that batch script gets submitted to the resource manager. The resource manager reads your batch script, figures out what you have you written it properly. Can it meet your requests? If you ask for 1,000,000 nodes, you'll probably get rejected because we don't have that many. So just sort of a quality check. And if everything is good, then your job goes into a queuing system where different prioritization implementations, depending on the system and the site and the administrative and the allocation rules and things like that. Your job goes into a queue and you have to wait. We're all real familiar with that if we've run jobs. If you're new, you'll get to know it. And so its job is to prioritize the jobs and make sure that there's a balanced workload on the system, and that people can get their jobs done in a reasonable amount of time. And you pay for that. If you want your job to go really fast, you pay a higher SU service charge. And if you're willing to wait, then you can save a little CPU time or units and have it run a little bit later. On Slurm, there's a lot of partitions, and note they're subject to change based on what we learn in the early user period evaluation. And I won't go through all the details of that, but there's the compute shared, GPU shared, and again, they have different charges, and there's different differences in how they might run. And we're learning about that right now in the early user phase. There's large memory nodes as well on Expanse. And there's the good old-fashioned debug queue. So they're pretty similar. And you specify them in your batch script. So to submit a job, you use sbatch. To check on it, sq, and then you can cancel. Looks like repeating some information there. But this is to show the job going from pending to running. When you're a new user, it's often frustrating, and you have to run this command many, many times while you wait. If the system's very, very busy, you can be waiting a long time. And so if you're waiting to see things running, and you would be using this queue system to get an interactive node as well. We're trying to prioritize interactive nodes on Expanse, and so we're going to be learning about how good a job we're doing on that as well. So here's an example batch script. Each one of these samples, the examples that we've given you, there's a batch script that goes with it that shows the batch. This #sbatch is a keyword to the Slurm processor. When it sees #sbatch, it knows, okay, this is something I need to parse and make decisions. You can put Unix commands in here, like I've done here. This is a do nothing script, except it does show you how the Slurm queue works and what machine you're on. You can print out some basic information. Anything that you can put into a bash script, bash, B-A-S-H script, you can put into your batch script as well, as long as you don't have a collision with the batch environment that gets set up. So you have the name of the job. You can choose what you want. The output file name, you can make it what you want. You can use the job ID and the node information. You can pick your partition, how many nodes you want, how many tasks per node, and then the time that you want. And over here, yes, indeed, I printed out some information and I could see my environment. Again, sometimes you need to know what's my environment, because if you haven't got things set up right, there's a difference between an interactive login, which would be when you log in with SSH, and a bash environment that you inherit when you have a job submitted by the Slurm batch queuing system. And if you think about the complexity of all of these components, your bash environment can get hammered. And so you may need to be checking it all through the different layers of software that you're working with. Okay, so a couple of hands-on examples. And I'll try to get through a couple, and we're pretty good on time. We'll have a few minutes at the end to have some questions. So for the code, if you've downloaded it and checked it out of the repository, you want to go into, for example, the MPI and look at the code. You want to make sure you've got the right modules. This is like a formula. Compile it. You'll know if it doesn't compile. And then you can see that you did get something compiled, and then submit the job to the .sb typically means a Slurm batch script, and you submit that to the SBatch submits this to that queuing system. Okay, so let's look at an MPI job. All of my examples are hello world. Most of the examples in there are hello world. And I've tried to run this for as many different compilers as possible. For our hybrid, it's a little more complex than Hello World, but you need to know when you log on, the biggest piece of advice I can give to you is have something that when things are all right, it runs every time. And that's the equivalent of a hello world. For your application, you should think about, gosh, when things aren't working right and it's crashing and you're not getting the right answer, what's your unit test case or hello world? And so there's something that should always work. And if it's not working, then there's maybe something wrong with the system. And if you're new to HPC systems, the layers of software and tools and hardware, it gets pretty complicated debugging your code. So my advice is always think in terms of a unit test and make sure you've established code that will work. All right, so this is Fortran, and these are the hopefully familiar MPI commands to initialize, get the number of cores you're running on, and the rank of the core that this is running on. And it's pretty straightforward. But a lot gets learned if you can't compile and make that run. So here is a README text. By the way, Mahidar put a lot of these READMEs and examples together for this webinar, and I really want to thank him for that. So he's got a step for compiling. You have to load the right environment, and then here's the compile step. And then in this case, I put in an example for running using Slurm, and also to run it on the interactive node. And those are, of course, a little bit different. And then here is the environment for compiling, which I did manually. And then we're going to, here's my batch script for running the Hello MPI Slurm with a GNU compiler. And so everything here looks pretty familiar. We're loading in the right environment, making sure I have the GNU. Since I was playing with different compilers, I added the compiler type to the name. And then using the srun command on the batch queue, here's what we specified for running this job. And then I submitted it. I got a batch job number. I monitored it to see it was running. And when it was done, I have the output file, which I put in hello MPI-GNU, the job ID, and the node number. You want to know that you're on a compute node, and all the output from 256 cores, and noting that the output from the queuing, the batch, the nodes, it's non-deterministic. There's no way to control the order in which material comes out. So if you need to control that, you have to really think about how you generate your output, A, or B, sort your data when you're done. So here I'm requesting an interactive node. So to do that, I have to have my environment. So I've loaded in the same environment that was in the batch script here. And then I use the srun command I ask for one node with 24 tasks for 30 minutes. And after a while, sometimes it takes a while, sometimes it doesn't, I get an interactive node, and I can tell I'm on it because I'm no longer on a login node. And by the way, there's two login nodes, login 1 and 2. They see the identical files, but it's just a load balancing system. So I know I'm on an interactive node. And in this case, on the interactive node, because I've loaded the right environment, I could just use MPI run and run my hello MPI and do other interesting things like maybe load a Singularity container or run a Jupyter notebook or something like that. We'll talk about some of that later in other training sessions. I do Jupyter notebooks in December. Be sure to exit that interactive session when you're done, or you'll be charged that full CPU time. And beware of oversubscribing your job. If you ask for more cores, like if you're doing an OpenMP application, it may try to run or it may just crash. So again, OpenMP, in this case, I went into the OpenMP directory. So same kind of code, except now we've added some OpenMP directives to print out the OpenMP thread numbers. It's a little bit different. Hello world, it's just a hello OpenMP. And the README script following this format, you make sure you know what the modules are. And here is the compiler command. It's Fortran, so we use F language. You have to include a link to the OpenMP libraries, and then the rest of it looks pretty familiar. Submit the job to the batch queue. We could do this on the interactive node. I don't have that example, but following the MPI one, you can do that. Oh, this is my compile command. I'm sorry, my brain just went to sleep. And then you want to make sure that you're controlling your threads by binding. And here's the batch script. Sorry. This is from Comet. I haven't updated that slide. Okay, so here's the batch script where we're using, in this example, a shared partition. Didn't have to, but we chose to use shared because that's a little bit cheaper. And maybe using shared partition, you don't care about performance as much as just getting an answer. And so you're willing to wait a little bit longer. And so here's the modules that you need. You want to make sure that you're setting the number of threads. So in this example, we're using the export command. And then we get the node, and in the OpenMP scenario, you just run the code from the command line, basically. And here is, looks like that was supposed to be output. So here is the file, and there's the output that we got from the sbatch command. Okay, so GPU CUDA. Here's the GPU type. The GPU nodes, we have 52 nodes, and they're NVIDIA V100s, and they have a large local storage on each one of them and a high bandwidth connectivity. So they're allocated as a separate resource. And you can define whether you want to use GPU or GPU shared partitions. There's the interactive command. And here is an interactive node example. So I'm down in my folder, I grab my interactive node. When I get it, I'm on an interactive node. And you can find out information about your node with NVIDIA SMI command. And then I'm down in this OpenACC example. So this one is running a little Laplacian 2D transform. In here, there will be some output that tells you things are working right. I had to snip it to fit it, but these are the modules you need to load in the compiler command using a Portland compiler command and some arguments for this particular application. And there is the batch script on the left, and the naming partition GPU shared. If you choose GPU shared, your job might run faster. I have to make sure I've got the right modules, and then I can run the job. I get my job, and here's my output showing you that it ran. Okay, we have a hybrid example. Excuse me, MPI OpenMP. Same thing, you got the batch script, you got the module configuration, you want to compile it, you want to submit it, and then you get some output for that. And data and storage. So Expanse is data-centric because we know that data is the future. Everything is getting larger and larger. So we have a Lustre parallel file system of 12 petabytes, 140 gigabit per second bandwidth, 200,000 IOPS. A lot of our workload on Comet is dominated by small files. And so we have a parallel file system dedicated to that. The FastIO nodes local, you have local storage on your nodes, and then we have a Ceph object storage. And this is just a little overview. I think I showed this earlier. We've got the nodes directly connected to the high-speed storage. And when you log in, you're in your home file system. You don't run your big jobs in the home file system. You'll have a maximum of 100 gigabytes in your home. Your work should be done elsewhere. Your work should be done over on your /work. If you look at the $work environment variable, you'll see where that is. That's on your projects directory. The parallel Lustre file systems are available for you to use. I'm going to rush through these so that we get done and get to some questions. You have local scratch on each of the nodes that you're working on. 250 gigabytes of SSD, that's all dedicated to your job. So if I/O is important in your application, use your local disk space to save interim data, and then move that to Lustre before you end your job. So that would be part of your batch script. So again, your batch script would have that one command that runs your executable, runs your code, and at the end of it, then you might need to add some steps to do file cleanup to move it from this local 250 gigabytes of SSD seems pretty good. But you want to make sure you take care of the cleanup. You can only access them during job execution. And there are some large SSDs on a few of the nodes. And you can request that by adding it into your batch script. We have Globus endpoints, data movers, and mount points. Globus is a good project for moving petabytes of data between distributed resources. And if you need more information on that, you can go to the Globus website. Okay, that's it. That's just about the end. So yeah, jobs are complex on HPC systems, but once you get to know it, it's not so hard. If you're new, welcome, and we'll try and help things go smoother for you as you build up your capabilities. That's the point of this webinar and some of our other beginner level tutorials. And there's a lot of other tutorials out there on Exceed especially. If you need help, contact the help desk. They're very helpful people and they respond very quickly. When things go wrong, check your user environment. Do you have the right modules? What software versions do you have? Does your Hello World work? Are you running on $home or $work? And run the jobs from the right location. So Lustre Scratch file systems, the compute GPU nodes have a location for data. The Lustre project, but not home user, not your home directory. Don't run code from there. Thank you. That's it. It's a quick dive into running jobs on Expanse. Here's some final links. And with that, I'll stop sharing and keep that. No, I'll keep this up. I'll keep sharing. I'll exit the training. Did I stop sharing or am I? Yeah, I stopped sharing. Okay, so at this point, anybody have any other questions they want to ask or?
Yeah, I want to say feel free to unmute yourself at this point if you'd like to just make it simpler than the chat. The chat was very active and I think it was mostly covered, but there may be some things that people would like to revisit for clarification. So if you want to unmute, go ahead.
Hi, Mary. I have a question. For people who currently have an exceed allocation on Comet, what do they need to do in order to move that if they will go past March of next year?
That's a great question. We have a transition workshop scheduled in about 2 weeks, and what we'll help people figure out how to do that. But basically, you get your account on Expanse, and you make sure you can access the Lustre file system, and then you'll have to figure out how to transfer your files between Comet and Expanse, and we'll be putting all that tutorial material together. And I think you'll have to figure out, you could use SCP for smaller files. You might need to use a data mover or a Globus endpoint for extremely large. And we'll work with you for each of those. And Mahi, Marty, Trevor, if you guys have any comments you want to add to that. It's a big topic of discussion on the Expanse team, by the way.
And so what is the deadline for the transfer of those files? Is approximately March, is it?
Approximately March.
Yeah,
Okay,
I would say that. And we would, initially when there is an overlap of both the Comet and Expanse file systems, the Globus endpoint for Comet, actually we're in the middle of doing this. We'll have the mount. And then, of course, once Comet is gone, Expanse will have its own endpoint.
thank you.
Thanks.
I was also thinking, is there anything we need to do from the exceed perspective with our allocation in order to change it from Comet to Expanse?
Yeah. Go ahead, Mahi.
So Mona, you're thinking of transfers, is that?
No, right now our allocation is on Comet, and it will go past March. So do we need to do anything from Exceed?
Oh yeah, so we'll contact everyone who's got Comet allocations that go past March and move them to Expanse.
Okay.
Yeah, so there are a few allocations periods where there was overlap, and yeah, I know there are quite a few allocations which will go past March. So any remaining time at that point will be moved to Expanse.
Okay, thank you.
And we've been kind of managing the allocation amounts on Comet to reflect the fact that we have only 6 months to go.
And again, in 2 weeks, we'll have our transition workshop, and I'm sure a lot of the questions asked today are going to provide great feedback to the transition workshop. And I hope to record each of the presentations and then turn them into an online tutorial repository where you can come and view the videos. And then we'll offer that a couple more times, I think, before, at least one more time before we get to the end of Comet. We know this is a big, important issue, so.
Yeah, all right, thank you, that's good.
Yeah, good question. Anybody else?
I have a quick question. Sorry about the noise in the background.
No, that's me. I have a helicopter.
Oh, I mean, good. I have noise too. It is not coming through. I was wondering, so I'm a professor at a mostly teaching university, and I was wondering as far as getting like undergraduates involved with like Expanse or high performance computing systems, should we go through Exceed or should we go directly to SDSC?
I think it's, are you thinking of using it in a teaching situation? Yeah, you can apply for educational allocations through Exceed. I think that's the best option. And
I'm in a similar situation, and I've had some good experience with my research students being able to get their own separate allocations on Comet, and I presume the same kind of thing would happen with Expanse.
You mean?
And you go through Exceed, like
yeah.
Right, okay, have an allocation, but then you need to write a little bit of an extra thing to kind of go on your allocation specifically for your student being able to do some research on their own account. It worked well for me anyway.
Good. Thanks a lot for that tip.
Sure.
Yeah, you can use the educational allocation for teaching a class, which I did several times when I was teaching at San Diego State University. And then I also use the educational allocation for students doing research like I think that was Johnny Powell
Right.
said, there's a limit to the number of projects you can be a PI on, but you can sponsor a graduate student, for example, to have their own allocation. And there's also startup allocations, which is another mechanism. They can be 1 to 3 years in length. And they're really great ways to take some time to figure out how your model would move to these systems and how it would scale before you enter into the full-blown allocation process.
Yeah, I'd really like to underscore that comment. I think the startup allocations on Comet were absolutely spectacular. I mean, the grant process is like so streamlined and so quick. And I think it's fantastic that Exceed has made it so that the startup allocations can last a little bit longer. Like I think
Yeah.
when I first started, they were like only a year, but I ended up having to use 3 years, but that's I needed that much time. So that was great.
Yeah. And the educational allocations are extremely easy to renew. Another way to connect your university is to identify a person to be a campus champion, and then your university can enter into a program with Exceed where you're a campus champion. And that campus champion person is essentially the PI, and they get an allocation. So people who just want to get on and try something really quickly, then the campus champion can bring them onto the allocation. It's like a 1 day ordeal or a day or two, but you add them and then Exceed manages getting the accounts. But that's another way to bring people in as well.
All right. Well, thanks a lot. I got to go. This was really good. I'm looking forward to those transition webinars. So,
Great.
thanks.
Thanks.
I had a question about the Slurm modularization. So is that that seems to me to be the main difference between Comet and Expanse is that we're loading the Slurm as a module interactively, correct?
Correct.
Yes. So you have
So
to.
that's really confusing to me because how am I when I go into the login node? I think you said in your first slide we should put that in our bash RC as like just something that always happens, but well, the first time I log into the login node, I'm not even going to be able to run like a skew command, right? I have to load that module interactively for every single, whether it's a login node or a compute node.
Yes.
And that's kind of confusing to me because I'm wondering what's the inspiration for that? Why isn't it being loaded by default? Is that because there's other types of scheduling systems you're experimenting with? Is that, and then how do my modules, like if I'm running a compute node and I forgot to load Slurm or something in the compute, but I did it in the login, how is the compute communicating with the scheduling process? And I'm just really curious about how that's all working on the back end.
Mahi, you want to take that, or
I was seeing if Trevor would jump in, but anyway.
Trevor? Yeah, you can, Trevor, if you want.
The reason there's a module is basically because Slurm is actually not in the standard location. It's kind of being, the installs on Expanse are basically managed by Bright, and the location of Slurm is different. So you guys essentially need a path addition to access it, and that's in a module to make it simple. In terms of I think you can just put that in your bash RC. That's the easiest thing to do, I think. It'll work fine with that. But in general, I would say do not put too many modules in the bash RC, especially like specific compiler versions and things, because I don't know if you picked up on it, but basically the GPU and CPU module stacks are completely different. The reason being they're different processors on the nodes. So you really need to get in the habit of putting everything into your Slurm scripts. So the environment you need should go into your Slurm scripts. So that's a big change from Comet. I mean, in Comet, you had everything in one place, in one stack, but here it's quite different because the processor is different.
Yeah, that's a really big change. So what's the exception if I run a compute job that didn't, like I run a virtualization and I forget to put Slurm module? Does it not show up in SKU? Like how would I be able to
Oh,
debug
no, no,
that?
it'll be fine because the submit time is what matters for the Slurm part of it. So once it's in the queue, Slurm will take care of it on the back end. So you
Yeah,
don't have
yeah.
to,
If you're not calling Slurm from your batch script, then you don't need
yeah, then you don't
loaded.
need. Now, if you
Okay.
had an S run in your batch script, then it will fail because it won't find the path to S run, basically.
Okay, yeah, because I do a lot of S runs and S batch submissions, so
Yeah, so yeah.
that will be pretty important to remember to do that every single time. So we should put it in bash RC. It's not, but I'm still curious. Why isn't it just in like etc profile for every single user?
We might
Why?
actually end up doing that. So
I think if you think ahead to cloud computing and using Jetstream or OSG or Google, they have different queuing systems, and Trevor has been, facing this. And so being able to control the complete environment and all of the software dependencies, that's one of the biggest issues is you get out 2 or 3 layers of hardware, software, or a combination of the two, like a tightly coupled model system of models. You have to be able to control the software environment, and you may not be able to if you're jumping over to several other systems. So this gives them a mechanism to control it. Remember that software dependency gets taken care of. So if you all of a sudden you're not using Slurm, you need to use the Jetstream queuing system or Condor, for example. That's completely different. So I think that's part of the reason they designed it this way. And I don't know, and maybe that's why we chose it for Expanse. I wasn't
one other thing I want to add is in terms of environments between CPU and GPU, even the compiler versions are slightly different. So you kind of have to keep that in mind. The Intel compiler on the GPU side is a different version than the one on the CPU side, and same with the GCC. And the reason is the CUDA compatibility. So, so on the CPU side, we needed GCC 10.2 to get the AMD ROM specific optimization flags. So that's why the bulk of the stack was built with GCC 10.2. But on GCC 10.2 is not supported with the CUDA version that we have on the GPU side. So that's why it's built with 8.3.1 on the GPU side. So yeah, there are certainly things to keep in mind because it's a heterogeneous architecture. And that is the reason to also compile specifically on a GPU node so that you get the right environment. Because if you kind of do a non-specific module load Intel, you may get the wrong one and then have an issue at runtime.
I have a question.
Yes, please go ahead.
Yeah, is the early user program available now for Expanse?
I mean, we just closed it actually, but you can do a startup basically, because early users we started getting people on in a couple of days ago, and it goes for 30 days. So we kind of had a limit on the number of people in the early user side, but you could definitely apply for a startup, and that will get you going, I think.
Okay. Well, we have to start using it to try out some of the programs before October 15th to submit the new proposals.
So do you already have commit time or bridges time?
Yes, yes.
If you do, I think you can use that scaling data as a starting point, and that's okay. And we will definitely let the reviewers know that that's what's coming, because we do recognize that there's no hardware to test either for, I mean, since it's too late to kind of do the benchmarking right before the deadline.
Great.
Yeah. And if you have any access to an external resource, some other resource that has AMD ROMs or V100s, you can definitely use that info also.
And some of it is in the literature. So can we use some of that too? That's already been benchmarked.
If it's a benchmark, you should. I mean, I would say include both what you have on Comet/Bridges and the one that's published, so that you can kind of make a case based on the combined information.
Great.
Okay, I have a question also. For asking for the educational allocation and also startup allocations, if we are already a user of some allocation in Bridges, does it affect our accessibility or the possibility of getting the startup or the educational allocations?
So you can always do a supplement if you already have a allocation. So that's
And for
quite possible. Yeah, Nicole, go ahead.
yeah, for startup, you can do the supplement. You cannot ask for 2 startups. But for the education, if you already have a startup or a research, you can ask for educational still.
Okay, so because I'm not the PI in the allocation that I'm using currently, and so if I want to
make
ask
sure
for,
it's not overlapping research.
oh, okay, yeah, definitely. So for the startup, I should ask separately, right? I should not go through the allocations I'm already using.
If you already have one and the PI is willing to request the supplement and it's going to be research that's similar, you should stick with the project you have. So you cannot request 2 startups for the same research project, regardless of who the PI is.
Yeah, so what we have now is mostly CPU, and the project we are going to start will be mostly, the code is mostly GPU based. So
but
I guess that would be 2 different projects.
So the resource that you use to do the research doesn't matter. It's what your research, the underlying research is.
So if the underlying research is the same, I think the best option is to do a supplement.
Yes.
So you can just take your current project and do a supplement request and ask for Expanse. I think that's perfectly fine, and that should be okay on our end also.
Okay, thank you.
So I just want to say that we will be making the slides and the recording available as soon as possible after the event. I'll keep recording for as long as we have questions, so if people need to drop off, thanks for joining, but if there's still more questions, feel free.
I actually had a question.
Oh,
sure. Go ahead.
Yeah, sorry. I am part of the EUP, and I want to make sure that the scaling stuff that I'm working on right now isn't putting up any flags. I don't seem to have access to the Scratch folders, neither the base Scratch or Expanse Luster Scratch username.
Oh, so I will go check on this, and we can contact you directly. We should.
Okay, cool. Yeah, I just wanted to,
probably
because I see the username folders. I just didn't have access.
Okay.
Yeah, did you check under the temp? So under Scratch, the username and then temp project. Do you have access under there?
What comes before username?
Scratch. So it's Expanse, Luster, Scratch, username, and then temp project. And under there, you should maybe have access.
Yeah. So the permissions are denied at the username level.
Okay.
Yeah, that's expected. So,
that's
yeah.
So you have to go to the temp project.
Ah, my mistake. I'll check. But if I have more follow-ups, we can email about it. Thanks, y'all.
Sure. Yeah. You can send in a ticket to help at Exceed, and we can follow up.
Got it.
Yep.
okay, if that's it, thanks everyone for joining. Thanks very much, Mary. Thanks, Mahi and Marty and Trevor and Nicole, everyone. And like I say, we'll make all the details available soon after through email. So thanks again.
Thanks.
Thank you. Okay, bye-bye, everybody. Thank you so much for coming.
Thank you.